The right triangle. Solving triangle is solving for all unknown angles, all unknown sides. So you are usually given 3 parts in a triangle and we need to solve for the rest of the other 3 parts. In right triangle particularly, we know that one of the angle is 90 degree. So in order for us to solve the triangle, we need to know other 2 parts. Some tricks to remember is sum of all angles for any triangle is 180 degrees. For right angle triangle, because one angle is already 90 degrees, remaining 2 acute angles will add up to 90 degrees. We use capital letters for the angles and small letters for the side lines. So if we have this kind of right angle triangle, let's say angle A is 90 degree here. Opposite of angle A, we use small letter A as a side length. Opposite of angle B, we use small b, and opposite of angle C, we use small c. Now we are so used to Pythagorean theorem saying a square plus b square equals c square. But that is when angle C is 90 degree. In this case, because angle A is 90 degree, my Pythagorean theorem will look like this. A square equals b square plus c square. Okay, so steps for solving right triangle. We first sketch the right triangle. We label all known and unknown sides and angles, and then we express each of the 3 unknown parts in terms of known parts, and then we solve. Okay, again, the 2 tricks to remember is all angles will add up to 180, and we can use Pythagorean theorem for right angle triangle. Let's see example here. We are asked to solve these right angle triangles, different ones. Given angle B is 90 degrees and we are asked to round our results to 2 decimal places. Okay, so this is our question, for example. So as we said earlier, first thing we'll do is we'll sketch a right angle triangle. Let's say this is a right angle triangle. Okay, and we will label A, B, C. Because we are given angle B to be 90 degree, B has to be here. A and C can be anywhere. Okay. Now for angle A, we are given it to be 28.3 degrees. So this here is 28.3 degrees. Okay. We are given side length C to be 10.98. So this part right here is 10.97 degrees. Or 10.97 as a length, not a degree. Degree is the angle. Length, because we are not given unit, is just 10.97. It could be meter, centimeter, it can be any unit. This right here, we need to find its B. This right here, we need to find its A. And we need to find angle C. The easiest here to find is angle C because we know 2 angles. Angle C will be 180, subtract 90, subtract 28.3, or we will remember that because one angle is 90, other 2 acute angles adds up to 90 degrees. So I'll say angle C equals 90, subtract 28.3, and all of these are in degrees. We get 90, subtract 28.3, we will get 61.7 degrees. So this right here is 61.7 degrees, and that is angle C. Now remaining is to find A and B. Doesn't matter which order we find them. Let's say we decided to solve for A first. In order for us to solve for A, again for right angle triangles, we need to use SOHCAHTOA. Sin theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan theta is opposite over adjacent. So from perspective of 28.3 degrees, A here is our opposite. This is my opposite. B is the hypotenuse, we know that's the longest side opposite of right angle, and 10.97 here is our adjacent. This is our A. So because I want to solve for O and I am given A, between sin theta, cos theta and tan theta is the one which will connect O and A. We know tan theta equals O over A, opposite over adjacent. So in our case it will be A over 10.97. So we can say then 28.3 degrees multiplied with 10.97 will be A. So then A will be, so in our calculators we punch in 10.97 times 28.3 degrees. The result we get is for A, then we are asked to round to 2 decimals. It will be 5.91 and we don't know the units. It's not degrees, it's a length. Now we have two side lengths. Third side length we can use Pythagorean theorem to solve. However, if we use Pythagorean theorem, if we made mistake in solving A, we'll make that same mistake carry over for B. So I'll avoid to use A. I'll start all over again. I'll find B from the given information. So from 28.3, this is hypotenuse, this is adjacent. So the one which connects adjacent and hypotenuse is cos theta. So I'll say cos theta equals adjacent over hypotenuse. So in our case, cos 28.3 degree equals adjacent is 10.97 divided by hypotenuse is B. Now cross multiplying, we can claim B equals 10.97 divided by cos of 28.3 degrees. Now punch this in our calculator, see what we get. 10.97 divided by cos 28.3 degrees. So the result we get here is 12.46. Okay, and again, because we don't have units for the side length, that's all we get. So we got angle C to be 61.7, we got A to be 5.91, and we got B to be 12.46.